Hello everyone, welcome back to another Project Gladiator weather forecast. Today I'll be covering the weather for January 8th of 2024. Starting off with the severe weather outlooks for today and the rest of the week. Today we do have an enhanced risk extending from the Florida Panhandle into the Houston metro area of Texas. Threats for today do include a 10% tornado risk with a hatched area for the possibility of EF2 or EF2 to EF5 tornadoes within that area, so we could see the possibility of a strong tornado or two, with the general rule of thumb being that weak ones are particularly expected if you do have this hatched area, and this is going to be the primary threat that we are going to be watching out for today. We also do have a 30% wind threat for the enhanced risk area, for the hashed area for the possibility of wind gusts greater than 65 knots or higher. So this does mean that we could see the possibility of some fairly strong wind gusts in the enhanced risk area, and that is going to be another risk that we will have to watch out for. As far as hail, we do have a 15%. This is going to be a little bit more of a secondary risk, and not really all that much of a concern considering the other threats for today, but we will have to watch out for this hail risk. For tomorrow, we do have a fairly large enhanced risk for a very good portion of Florida, southern Georgia, South Carolina, North Carolina, as well as southern Alabama. Threats for tomorrow do include two areas of a 10% tornado risk with two hash areas where we could see the possibility of a strong tornado or two, with again the general rule of thumb being that weak ones are expected. As for our damaging wind threat, we do have a 30%, and this does seem to be overall the driving risk, right next to the tornado risk. With the 30% damaging wind risk overall encompassing pretty much the entire area, much larger area than the tornado risk. So we will have to watch for both the tornado and wind risk for tomorrow. It may be impossible for me to go live for this event for tomorrow. I am planning on going live the second I do get this video out for today's event, but it seems pretty unlikely that I'll be able to go live for the event for tomorrow. So I am sorry about that. However, there are channels that I highly suggest you check out for any live footage or live coverage of this event for tomorrow, such as Max Velocity, Ryan Hall, and generally any other YouTube channels that go live for severe weather events. But we do have the hash area for the 30%, so we could see the possibility of some strong damaging wind gusts. As far as hail, we do have a small 5% for the Florida Panhandle into southern Alabama and southern Georgia, so overall not really all that big of a hail risk for tomorrow. As far as day 3, no organized severe thunderstorms currently forecasted, and I don't think we're going to see any areas forecasted for severe thunderstorms on day 3, but we could see the possibility of some general thunderstorms and rain showers along the Pacific Northwest coast. And then for day 4 to day 8, this is going to be fairly concerning because we do have a day 4 outlook. Day 4, 15%, which is a slight risk for eastern Texas, Louisiana, southern Arkansas into Mississippi. And then we also do have a day 5 outlook for the deep southeast again for Mississippi, Alabama, Georgia, North Carolina, South Carolina, as well as northern Florida. So we will have to watch that over the next couple of days. Overall, I'm not really too sure about this setup. I do think it's overall going to be lower compared to what we are seeing as of right now, but we will have to watch this over time. Taking a look at our WBC outlook, starting off with our excessive rainfall forecast. For today, we do have a moderate threat for southern Mississippi into the Louisiana region. This does mean at least a 40% chance of flooding, with the possibility of significant flooding with that moderate threat area. So that is going to be another threat that we are going to have to watch out for today. Is going to be the possibility of significant flooding. Then for tomorrow, we do have two areas of a moderate threat. We do have this very small localized moderate threat for North Carolina, northern Georgia into southwestern North Carolina, as well as a much larger moderate threat extending from Virginia into Rhode Island and Connecticut for a very large portion of the coastal regions of the New England corridor. And we will have to watch out for that for tomorrow, and I will likely have a forecast on this for tomorrow. As for day 3, we do have a slight risk for southern Maine into New Hampshire. And then for winter weather outlooks, we are expected to see quite a bit of heavy snow associated with that significant winter storm that we are seeing blow through the Central Plains into the Midwest. I will likely touch on this a little bit in today's forecast, but overall I won't really be going too in depth in it. For tomorrow, we are expected to see that system move up into the Midwest as well as impact the New England corridor, dropping a ton of snow through Maine into New York, as well as for the upper peninsula of Michigan and northern Michigan back into Wisconsin. Then for our day 3 outlook, we aren't really seeing anything as far as significant snow patterns. But something I would do want to note outside of that significant blizzard is that we are expected to see an absolutely ton amount of snow across the Rockies. But overall, I'm not really going to be touching on that all that much in today's forecast. And then we can also take a look at our surface analysis real quick. As for the latest outlook, as for our surface analysis, we are going to have to watch this cold front as this cold front continues to push eastward over the next couple of hours and move into the area of concern. That is going to be the primary triggering factor for those more robust systems. We are going to also have to watch for some more discrete storms in the warm sector. However, overall, the ones that have been developing aren't really all that robust, but they may become more robust over time. So we will have to watch those. But overall, the main concern should be along the cold front. And again, that surface low is going to continue to push eastward. And that surface low is going to cause some strong warm air advection out of the Gulf of Mexico. And that is what is going to be providing our heat, moisture, and instability in the warm sector to fuel our severe thunderstorms. Taking a look at our weather model, starting off with our 500 millibars like we usually do, and then we'll go to our low level jet and then our upper level maps in the 200 millibars. So starting off with our 500 millibars, we are seeing this upper level trough situated around Oklahoma into Texas, somewhere in the Central Plains. And this does have a fairly strong jet streak associated with this. And this jet streak is expected around the base of this trough and become, as it becomes negatively tilted and push eastward, driving that cold front. And as that jet streak rounds the base and that trough becomes negatively tilted, it is expected to increase quite a bit. And current models are indicating that we could see a 500 millibar jet streak upwards of 100 to 140 to 150 miles per hour. So as that mid-level jet streak does increase, so will the risk for severe thunderstorms. So we will have to watch our severe thunderstorms as they do move into this enhanced risk region as that 500 millibar jet streak increases. And you can see the sheer strength of this trough, especially at the 500 millibars, with the wind speeds upwards of 120 knots to 140 knots. Coupled together with the very, very prominent veering of the winds. And again, the overall just strength of this trough, we are expected to see a ton of directional shear, aided with our low-level jet as well. As for the snowstorm that we are expected to see blow through the Central Plains into the Midwest, as this trough does advect to the north and to the northwest, on the northward side of that trough, it should lead to all those snow showers to the north of that trough. And as that trough moves eastward, as that trough moves northeastward as well, it should drive all of that snow into the Midwest. Taking a look at our low-level jet, we are expected to see our low-level jet begin to increase around 10 p.m. tonight, around 10 to 9 p.m. tonight, and that's when the overall threat for severe thunderstorms should begin to increase as the low-level jet increases, because that will enhance shear and enhance the low-level curvature of the hodographs and really start getting those storms really, really going. Even if they aren't going already, which they definitely are, they are expected to increase in strength as this low-level jet increases. And with the sheer strength of this low-level jet, again, we are expected to see a ton of shear come out of this, and we should definitely see the threat for tornadoes because of this. And our low-level jet is going to be quite strong as well. So even if it wasn't already apparent, we are expected to see a low-level jet that could potentially see a strength of wind speeds upwards of 120 miles per hour, which is extremely strong for a low-level jet. And again, that should provide a absolutely insane amount of directional shear to this region, as well as speed shear, which should help keep storms organized. Taking a look at our 200 millibar maps, mainly focusing on the exit region of the trough and the defluence that we are expected to see in the exit region of that trough. Follow the wind vectors here in the isobars, and you can see the spread of those wind vectors and isobars. And you can see how it just points an absolute fire hose into the deep southeast. Because of the spreading of those wind vectors, not only will that help with more upper levels shear, but that will also create a void in the atmosphere in the upper levels. And because the atmosphere doesn't like voids because it is a gas, it will use air from the lower levels, the mid levels, and anything above or anything below the upper levels. It will rise upward, and that's how you get wide scale lift with large amounts of defluence like this. So we are expected to see quite a bit of defluence, and we should see quite a bit of wide scale lift. And that should also be one of the things that is potentially going to help support those uh, more weaker end and less robust and more semi-discrete cells in the middle of the warm sector, but more information on those later. Taking a look at our composite reflexivity, I'm going to be going over the when and where. You should be able to see our severe thunderstorms up to around 5:37 p.m. EST is the time I am recording this segment. And I am going to be going over what we are seeing as far as the simulated radar and what everything currently means so far. So let's take a look at the timing as for the storms that are currently along the cold front. So these storms, as of right now, are expected to push out into the Atlantic Ocean along the cold front and mainly exit the Texas region around 9 p.m. tonight and move through central Louisiana around 8 to 9 p.m. EST. Everything I'm saying currently, as of right now, is in EST time, so please feel free to translate that over to Central Time or whatever time zone you are currently in, because I am not good at all with transitioning time zones, and I don't want to get anything wrong as far as timing and confuse you guys. Um, but as IQLCS pushes into Mississippi and more eastern regions of Louisiana around 10 p.m., that is going to be when the 500 millibar jet streak, as well as the low level jet, is increasing to really big strengths, and you can really see the robustness in the organization in that QLCS along the cold front as it does move into eastern Louisiana. And again, that is going to be something that we are going to have to heavily watch, as we could see some spin up along the QLCS, and that is going to be our tornado risk. And this is expected to move into eastern Louisiana around 11 p.m. And then you can really see how it becomes organized as it moves into Alabama and exits into the Gulf of Mexico out of Louisiana around 5 a.m. In the very early morning of tomorrow. And this is going to be the start of the severe weather risk that we are expected to see tomorrow, as that QLCS organizes and really strengthens with that 500 millibar jet streak and that low level jet behind it. Again, we could see the possibility of some embedded tornadoes, some of which could be strong. And again, that is going to be pushing into southern Alabama and into the Florida Panhandle around 7 a.m. EST. Um, so as far as the simulated radar and what everything is currently meaning, let's push it back towards around 8 p.m. As what I was mentioning towards those semi-discrete supercells ahead of the cold front in the prefrontal zone in the warm sector, are all of these somewhat hooked and very weakly robust storms that are currently indicated in the warm sector ahead of the cold front across Louisiana into southern Mississippi, with some of them being robust, but overall they are mostly fairly unrobust and fairly unorganized. We will have to watch this as far as how it might affect our instability and how they might affect our tornado risk, because some of these may have the potential to grow into some fairly big storms, because in the warm sector, these storms that are semi-discrete in the warm sector will be able to use the warm air advection and the moisture and the heat and the instability directly provided in the warm sector. It won't have to rely on the cold front for initiation, so we will be able to use the instability and all the ingredients currently present in the warm sector to potentially become quite strong storms. And you can see as that QLCS does get closer to the Louisiana region, and that low level jet does increase, and that 500 millibar jet streak does increase. And shear increases. You can see the robustness of those storms ahead of the cold front does increase substantially. And again, because it will be able to use everything currently provided to it or directly provided to it in the warm sector, these could potentially be quite hazardous and will have to be watched, even if it isn't directly related to the cold front. Again, these could potentially be quite hazardous, and I am almost positive that almost all the storms you are seeing in the prefrontal zone are most likely supercells that are capable of producing tornadoes, especially the more robust ones. So again, those will have to be watched. And then we can also take a look at the timing as far as the snowstorms in the Central Plains today. We are expected to see a ton of widespread snow and a ton of heavy snow. This is expected to push into the Midwest region and really clear out of the Central Plains around 9 a.m. tomorrow. The reason I am concerned about how some of these more robust and more semi-discrete supercells might impact the instability of the QLCS and the overall organization of the QLCS is because these semi-discrete supercells ahead of the QLCS in the prefrontal zone again will be able to use up that instability, moisture, and heat in the prefrontal zone. And overall, I'm not really sure how that is going to impact the QLCS as far as intensity, but it does look like that model. It does look like models are indicating that the QLCS along the cold front should have no problem becoming quite robust as it does absorb some of those more semi-discrete supercells ahead of it in the prefrontal zone. Again, we will have to watch these semi-discrete supercells because, again, I'm not really sure how it's going to affect the QLCS. Taking a look at our dew points, I'm gonna start looking at the different contributing factors of the warm sector, what the warm sector is going to look like as far as thermodynamics, such as dew points, temperatures, as well as instability, and how our dew points and temperatures are going to be affecting our instability. So that is what I'm going to be primarily focusing on before we get into our more composite models and compiling it all together. So starting off with our dew points, we are expected to see some fairly nice dew points in the warm sector here. We are expected to see dew points in the prefrontal zone that are going to be getting upwards of the upper 60s and potentially getting very close to those very low 70s. Overall, I'm not really sure if they are going to reach 70s. It does look like they are going to stay mostly around the upper 60s, but they could become very close to the upper 70s. And overall, what we are seeing in actual reality compared to the simulated soundings and models, um, they have been uptrending quite a bit in overperforming as far as instability. We have seen upwards of 500 joules per kilogram of instability that has been observed in the real world compared to our models, what our models are saying. So this does have the chance to uptrend up to those 70s. We will have to wait and see what they will look like in actual reality. But overall, these do have the potential to uptrend. Taking a look at our temperatures, we are also seeing some fairly better temperatures compared to what we were seeing on our models yesterday. Again, our models have been uptrending quite a lot recently, especially compared to what the models were saying around midnight last night. They really have been uptrending, and we are seeing temperatures that are getting into those low 70s across eastern Texas, and then those temperatures are expected to push eastward as the warm sector pushes eastward, and that warm front pushes eastward. Those temperatures are going to they are going to stay mostly around the low 70s into the upper 60s. Overall, the temperatures on the models aren't really the best for instability, and our instability may potentially be limited. However, these are fairly good temperatures and should provide us with quite a bit of instability to fuel our severe thunderstorms. Even if they may not look the best, they are fairly good. And with the warm air advection that we are seeing deliver these temperatures and moisture to the prefrontal zone, we should see a constant replenishment of those temperatures, if they are of the heat, of the moisture, and of the instability as it is used up by some of those more discrete supercells in the prefrontal zone. And something I do want to note is that we are seeing very, very hot temperatures in the middle of January in southern Texas here. Temperatures upwards of 90 degrees Fahrenheit in southern Texas, which is absolutely absurd to see in the middle of January. So it does just go to show the absolute power that this warm sector does have with our warm air advection out of the Gulf of Mexico. Hopping back over to pivotal weather for a second, we are going to be focusing on our lapse rates and how that is going to aid in our instability a little bit. We are expected to see overall some fairly lower end lapse rates. However, it isn't nothing. We are seeing some somewhat steep lapse rates. Overall, they're not the best, but it isn't nothing, and they should definitely help with instability a little bit. Not only will it help with instability, but it could also potentially help with the hail threat as well, as lapse rates do increase that change in temperature with height. So it does lower the does overall lower the hail growth layer closer down to the air, or closer down to the ground, sorry, which does allow a strong updraft to aloft rain particles higher up into the atmosphere and allow them to stay in that hail growth layer for much longer and allow them to get bigger. So these stronger lapse rates are potentially going to help with our instability, but also our hail threat. Taking a look at our temperature advection models for our 850 millibars, you can see that the majority of our moisture, heat, and instability is advecting northward out of the Gulf of Mexico. And again, that's what's going to be fueling our severe thunderstorms. That's where all the ingredients for our severe thunderstorms are going to be coming from. And with this severe weather threat being so close to the Gulf of Mexico, which it kind of has to be able to get strong enough moisture, strong enough instability to really support a strong severe thunderstorm threat like this, we should see constant replenishment of that warm sector. Even if our discrete supercells in the prefrontal zone do use up a lot of that instability a little bit, it should be replenished by our warm air advection, hopefully. And again, our warm air advection is quite strong out of the Gulf of Mexico. You can see those really deep reds and getting very, very deep further north you go. But closer to the coastal regions, we are seeing some fairly strong warm air advection out of the Gulf of Mexico. So again, that should help with instability, and that should keep moisture, heat, and instability replenished in that prefrontal zone. Taking a look at our convective inhibition and how that is going to affect our storms that may be developing in the prefrontal zone, as well as how it may help with our instability a little bit, as our convective inhibition will prevent air at the surface level from rising freely, and that will help instability, heat, and moisture to build below that temperature inversion in the warm sector before it can be released by our cold front. However, overall in our warm sector, shore especially, we are seeing a very, very weak cap. Even if it is weak, it is still there. May help with our instability building a little bit. However, due to its weakness, it is going to allow air to rise freely, or rise pretty easily in the warm sector, and that is what's going to be allowing for that convection ahead of our ahead of our cold front, and that's what's going to be allowing for those prefrontal storms. Overall, the weakness of our cap may not really help with instability building a little bit. Again, it is there, it may help it a little bit. It is very, very, very weak. So overall, I'm not sure how much it will help with our instability. But even if it doesn't really help with our instability all that much, we should see that strong warm air advection out of the Gulf of Mexico, and that should really help with our instability quite a bit. But again, due to the lack of a strong cap, it isn't really it isn't really allowing the prevention of convection in that prefrontal zone. So that's why we are seeing some of those prefrontal storms in that warm sector. Taking a look at our most unstable cape, and then we'll take a look at our surface instability. We are seeing quite a bit of instability across this region. We are seeing cape values in eastern Texas that are getting up to the upper 2000s. In fact, earlier model runs were saying that they were getting up to 3000, which is pretty strong for January. Plus, as I mentioned previously, we are seeing significant uptrend in what we are seeing actually in reality with real cape values getting up to 500 joules per kilogram in the real world in our warm sector. That is absolutely insane for January. And again, with it uptrending so much, uh, we will only have to wait and see what we are going to see in the real world with the significant uptrending that we are seeing in our models. So, or significant overperformance, I should say. It's not necessarily uptrending, but it is significant overperformance in the real world. Again, we are seeing pretty strong instability in our warm sector, regardless of the uptrend in the real world, and it should definitely be able to fuel that threat for some strong tornadoes, as well as a threat for the general rule of thumb for some weak tornadoes, as well as the possibility of some large hail, as well as the possibility of some damaging wind gusts that could potentially be strong with some of the more discrete supercells, but it should be primarily along that QLCS is what the primary damaging wind threat should be. Taking a look at our 0 to 3 kilometer instability and our instability at the surface level, I am taking a look at this because it can be quite helpful when looking at instability because with some setups, you can have weak, most unstable cape, which we most definitely do not. Um, but strong surface instability, and that can fuel a severe thunderstorm threat by itself, even the possibility for tornadoes. So that is why I am looking at the surface instability because it can be quite an aiding factor in these severe thunderstorms. And you see that we do have some fairly good surface instability at the surface. Overall, it isn't strong, but it is definitely moderate, and it is definitely there, and it is definitely enough to fuel a threat for severe thunderstorms, especially by themselves. But with the fact that we do have strong, most unstable cape, we shouldn't really have to worry about surface instability. Um, but again, we do have very strong surface instability, or sorry, not very strong. It is fairly moderate, but we do have some pretty good surface instability, and that surface instability may even increase as the night goes on into Mississippi and eastern Louisiana and into Florida, and potentially help with our severe thunderstorm threat as that does move into Alabama and Florida. Now I am going to be taking a look at our speed shear, our bulk shear, and our directional shear before we take a look at our composite parameters, because we need both instability and our shear to get an idea of our composite parameters. So with the amount of instability that we have and it being quite strong, seeing this amount of directional shear, especially at 0 to 3 kilometers in the prefrontal zone, which some of those prefrontal storms can use up to start to rotate, but along the frontal zone as well, with being so significant as far as directional shear, this is very, very concerning because in some areas the directional shear is getting off the charts in those little small dark areas. Um, Again, we have insanely strong directional shear ahead of our prefrontal, in the prefrontal zone and along our cold front. So again, not only can those semi-discrete supercells use up some of that directional shear, but again, along the prefrontal zone, or along the cold front, we should be able to see some fairly strong spin up with this directional shear. So with the strong instability, especially at the surface level, as well as the insanely strong directional shear that we are seeing in the prefrontal zone and along the cold front, we are definitely in for the potential for strong tornadoes across the enhanced risk region. So again, very, very strong directional shear is definitely going to allow for the possibility of strong tornadoes in our enhanced risk area. And then taking a look at our bulk shear so we can get an overall idea for how it might affect our organization of the storms, not only in the prefrontal zone, but also along the cold front, as well as overall the general idea of our bulk shear so we can get an idea of our hail potential somewhat. You can see overall, before we get into the model scans where the low level jet and 500 millibar jet or 500 millibar jet streak increase, you can already see some pretty strong bulk shear back behind the cold front, driving that cold front forward. However, by the time that 500 millibar jet streak does increase and that low level jet increases, and we see that increase of shear, we have very, very strong bulk shear here upwards of 70 to potentially 80 knots, and back towards where that low pressure is, where it can't necessarily be used up because it's too far to the west. We are seeing upwards of 120 knots of bulk shear. That's absolutely insane and should 100% help with our organization, especially in the prefrontal zone. You can see that we do have a little bit less bulk shear in the prefrontal zone, which um, uh, does look a little bit concerning for some of those more semi-discrete supercells in the prefrontal zone. However, you can still see that it is going to be sufficient enough to help organize those storms in the prefrontal zone, and especially along the cold front, driving the cold front forward. Again, we have insane bulk shear, which should definitely help with a lot of the storm organization. And as far as elongated hodographs, and our potential for hail, again, very, very strong bulk shear, should definitely elongate hodographs, and should definitely support the potential for some large hail embedded in the QLCS, as well as possibly with some of those prefrontal storms. But overall, the main hail risk should be along those along the taking a look at our composite model so we could get an idea of the culmination of the instability and shear and everything that is going on in the environment, so we can get the best idea of how these are all going to culminate together. So starting off with our energy helicity index models on our 0 to 3 kilometers, you can see that we do have some fairly strong energy helicity index values back towards Texas and into Louisiana at the start of the model run, getting upwards of 4 to potentially 5 in some regions, which is fairly indicative of a good tornado risk. And then as that moves into Louisiana, that is expected to increase substantially, potentially getting upwards of 5 to 6. And then as that does move eastward, we are going to continue to see that increase substantially as our low-level jet increases and our 500 millibar jet streak increases, and we see the overall increase in our shear. That should also lead to the overall increase in the potential for tornadoes as it does move into southern Alabama and the Florida Panhandle, and we are expected to see the possibility of our energy helicity index values increasing upwards of 7 to potentially 9, and we do have some of these stronger areas, and that is associated with that possibility of some strong tornadoes associated with these systems. And again, as that does move into tomorrow in the Florida Panhandle, we should see some still fairly strong energy helicity index values that could be ranging anywhere from 7 to 5. So again, very, very strong energy helicity index values and very indicative of a strong tornado risk across the enhanced risk area. Taking a look at our STP, or significant tornado parameter, or SIGTOR, as some people call it, either one of those three ways are the correct way of calling this model. Um, I'm not really sure, to be honest, how it differentiates from energy helicity index values, other than the fact that it does have a different color table, and maybe the uh, the possibility of significant tornadoes. I'm still trying to figure out significant tornado parameter. All I do know is that it does culminate in stability and directional shear to give us the best idea for tornadoes, kind of like energy helicity index does. But I do look at it for some of these more significant tornado risks. So in Texas, we are seeing some fairly strong SIGTOR readings, upwards of 5 to 3. And then as that does move into Louisiana, we are expected to see that increase to values that could potentially be getting upwards of 6 to 5. Very widespread, and you can see the significant increase compared to Texas into Louisiana. And then as that does move into Alabama and the Florida Panhandle, in southern Mississippi, we are going to see a strong increase as that low level jet increases and our directional shear increases. Um, Very, very strong or SIGTOR readings here, upwards of 5 to potentially 6 and 7. So kind of similar to our energy helicity index values. However, very, very strong signatures that we are expected to see some strong tornadoes across this region. Taking a look at our total precipitation models, I'm going to be focusing on this so we can get an idea of the possibility for significant flash flooding in that moderate threat area. However, ironically, does look like that models are indicating that we are expected to see much more rainfall outside of the moderate threat area than inside of it. But we are still expected to see a ton of rainfall nonetheless, and definitely the possibility for flash flooding and the possibility for significant flash flooding in some regions, with rainfall totals that are expected to be getting upwards of 3 to 4 inches across the Dixie states because of these systems, which is very, very high. Like you can have 3 to 4 inches fall in a single week, and be fine. But having that fall in a single day, that definitely opens up the possibility for flash flooding. We can also take a look at our damaging wind risk as well, and our 10-meter wind gust. So basically, our wind gust that we are seeing at the surface level. So associated with this QLCS, which is going to be the primary risk for damaging winds in the 30% area, we are seeing some very, very strong prefrontal winds, especially along the front. But in the prefrontal area, we could see wind gusts upwards of 50 to 40 miles per hour. However, in some more isolated areas of the prefrontal zone, we could see upwards of 60 miles per hour or higher. And again, this doesn't really take into account the overperformance of instability and everything in the real world. So this risk may be higher. But again, along the cold front, we are expected to see some fairly strong damaging wind gusts, which could be upwards of 60 miles per hour. And then taking a look at our damaging winds associated with the snowstorm and the blizzard that we are expected to see blow through the Central Plains and the Midwest, you can see that we do have very, very strong damaging winds with this system as well. Um, because it is a blizzard, they do bring strong damaging winds, and we could see damaging wind gusts upwards of 40 to 50 miles per hour, which is quite strong and could definitely reduce visibility and definitely make roads fairly hazardous in the areas affected. Not only with the lower visibility because of how much snow we are expected to see fall. As well as it accumulating on the road, but all that stuff is going to be blowing around pretty violently. So it is definitely necessary to take precautions if you have to drive through this system. It isn't recommended that you drive through the system. I wouldn't recommend it. I highly suggest that you only drive through this system if absolutely necessary. And if you do have to drive through this system, please definitely make sure you are taking the necessary precautions because you may be taking necessary precautions. However, you don't know if other drivers on the road are. So definitely make sure you are staying alert if you do have to drive through this system. Taking a look at our total snowfall models, total snowfall models are definitely less compared to what the named 3 kilometer CONUS models were indicating around 3 to 4 days ago. Named 3 kilometer CONUS models were in some sort of fantasy land where it was predicting that eastern Nebraska could see upwards of 2 feet or higher of snowfall. Um, a foot of snow isn't out of the question. However, models are indicating that we are expected to see less than a foot of snow, and we should see snowfall associated with this blizzard that could be getting upwards of 7 to 8 inches across northern Missouri, as well as back into Kansas and into Illinois as well as southern Iowa. Those are the general areas that we are expected to see the majority of our snowfall for. And again, it could become quite hazardous with that much snow on the road. Now that I've told you the weather, please go down to the description and check out the socials for Project Gladiator and join the Discord for any updates on Project Gladiator. If you live in any of the areas that I covered for today, please stay weather alert for the time being. I will be going live for this system as soon as I get this video released. Two other channels that I highly suggest you check out are One Nation Weather and Weather Watcher. They make amazing weather content. If you notice anything might have been wrong with this forecast, or you'd like to make a suggestion or ask a question, please leave a comment, and hopefully I might be able to see you guys tomorrow with another forecast. Again, it really all depends on the plans for tomorrow.